So as I was saying before, I was so rudely cut off. So if I look at the slope, because of course I need to pay attention to what happens at this point where it changes slope because the functions change. And if I look at the graph, I go, OMG, I have a corner. And then if I look at what's happening to the derivative from the left, so the derivative from the left would be the upper piece versus the derivative from the right would be the lower piece. And so I'm just going to plug in that 1 and see what happens. So the left piece, I get a slope of 2. The right piece, I get a slope of 8. So of course that is a does not exist because it's not the same. So, oh look, I have a slope that is undefined or does not exist. Aha! I just found another critical value, that critical value being at x equals 1. So I had x equals 0 from setting equal to 0. I now have x equals 1 for the undefined. And then, of course, I have to check both endpoints. So I have 4 values for this table. Okay, see if you can fill out your table before you pause the video, before you come back, and I'll have it done for you. So I find this one kind of interesting that I got that critical value from the second part of the derivative, which was setting the 8x equal to 0. But if I actually substitute 0 in to the first derivative, first of all, I have to substitute it into the top piece because that's where 0 belongs. And of course, that slope was just a constant, it was 2. I find that kind of weird, don't you? And then if I plug in 1, remember I have to plug in 1 for the top version, so I also get a slope of 2 at 1. And then on the last one, oh wait, no, just kidding. I got it works in both, right? That was not a 2, it was an undefined. I just solved it, Torres. Wake up, pay attention. So I got an undefined. And then I don't need to worry about 3 really. I can plug it in. It would go into this second piece, so 8 times 3 would be 24. I don't really need to because that was just an endpoint. Now, I said I was going to have 4 points, but remember one of those critical values also happened to be, so it turned out to be a critical value and an endpoint, so I don't need to write it down twice. Okay, so now I have to find their y values. Remember, in order to find the y values, I'm substituting into the original function. So when I substitute 0 in, I have to substitute it into the top piece, and that'll give me 2. And when I substitute in 1, that has to go in the top piece too, because 1 is part of the top piece of my piece function, and so I'd have 2 plus 2, which is 4. And when I substitute in 3, I have to substitute it into the bottom, which gives me 36. So now I go, which one's the highest? Oh, 36. So that's my absolute max at 336. Which one's the lowest? Oh, that would be 2. That'll be 2. And so that's the absolute min at 0, 2. So simple. So I would like you to pause the video and try number 4 by yourself, remembering that you have an absolute value in that original function, which means before you begin, you must rewrite it as a piece function. All absolute value functions must be rewritten as piece functions. So try it first, and then you can go on to the next video.